In this video, I am going to show you how to find the general solution of a trig equation such as sin x is equal to minus a half. Because we know that there's an infinite number of solutions, the general solution gives that infinite number of solutions. But in some cases, we require a certain number of solutions within a restricted domain, such as 0 is less than or equal to x, which is less than or equal to 360 degrees. So I'm going to take you through the steps that you require to arrive at those solutions. So firstly, what I do is I will take down the equation sin x is equal to minus a half. The next thing that I want to do is find the key angle, which is found in the first quadrant, and that first quadrant angle is going to be the inverse of 1 over 2. And if you use your calculator, you'll see that this is equal to 30 degrees. So this is the first quadrant angle that will give us 1 over 2. Now going back to the original question, I'll see that sin x is supposed to be negative, and so I'm going to sketch my cast diagram and say that since sin is meant to be negative in the cast diagram, the required quadrants then are going to be the third and the fourth quadrant. Here all of them are positive, and so is this one here, it's positive. So I'm going to show that location on this new diagram here, and this is going to be inclined at 30 degrees here. So the required angle x is going to be equal to 180 plus 30 degrees, so that should give us 210 degrees as our first solution. The second angle is going to be found in the fourth quadrant, and it's going to look something like this here, and that's inclined at 30 degrees again to the x-axis. Now the required angle x is going to be this one here. It goes in this direction, and that is going to be equal to 360 degrees minus 30, and that should give us 330 degrees. Now the general solution is an expression that gives us all the values of x which will satisfy this equation. So it's going to take this form here. X is going to be equal to 210 degrees plus or minus n 360 degrees. 360 degrees because we know that the graph of sine theta will sine x in this case will repeat itself after every 360 degrees. Similarly for this one here, we are saying x will be equal to 330 degrees plus or minus n 360 degrees. Now to find these specific solutions from 0 to 360 degrees, we will say that n, maybe I need to add here that where n is equal to 0, 1, 2, 3 and so on. Now to find the specific values of x, I'm going to substitute the values, different values of n in this general solution. So for instance, when n is equal to 0, x is going to be equal to 210 degrees plus or minus 0 times 360. That just gives me 360 degrees. And similarly on this second equation here, if I say n is equal to 0, I'll have 330 plus 0, and that's also going to be a solution. When n is equal to 1, I'll put 1 here. It'll be 210 plus 360 degrees, and you can see that this falls out of the required range. If I say 210 minus 360, this is a number which is less than 0, so we are not going to get a solution. It is going to be the same situation in the second general solution. So these are the only two values that satisfy my given equation. Turning our attention to the second equation, I'm going to proceed in the same manner by looking firstly for the key angle. And remember, we have said that the key angle is going to be the acute angle found in the first quadrant. And so I'm just going to find the inverse of 1 over the square root of 2, and if you use your calculator, making sure that it's in degree mode, you will get 45 degrees as your key angle. Now we have to go to our original equation and decide in which quadrant the solutions are going to lie in. And you will notice that this is a positive cos theta, so it is going to be in this first quadrant here. So that is inclined at 45 degrees. And the second solution is going to be found in the fourth quadrant. Again, using the cos diagram, we can see that cos is positive in the first and it's also positive in the fourth quadrant. So this one I'm going to show using this green line here. So the required angle is going to be this that goes round, and it should be equal to 360 degrees. So that's 360 minus 45, giving us 315 degrees. Okay, so I'm now in a position to write down the two general solutions to my equation. So the first one is going to be this one here, 45. So I'm saying that theta is going to be equal to 45 degrees. Sorry, let's just maintain some uniformity there. 45 degrees plus or minus and 360 degrees. 360 degrees because cosine also repeats itself after 360 degrees. The other solution is going to be this one here. We will find that my theta is going to be 315 degrees plus or minus and 360. Now I'm looking for the values of theta which will satisfy this given domain here. I have to start from minus 360 degrees and stop at positive 360 degrees. So I'm just going to consider this first general solution here. Now when n is equal to 0, we will find that theta is equal to 45 degrees. Okay, now when n is equal to 1, on this same general solution again, we are going to have theta, we will have theta being equal to 45 plus or minus 360 degrees, because 1 times 360 is that. So I'll get two answers there. So theta is going to be equal to minus 315 degrees. If I say 45 minus 360, the other solution of 405 degrees is going to be outside the required range. Now let's look for solutions in the second general solution. Now when n is equal to 0, you're going to have theta being equal to 315 degrees. Now when n is equal to 1, we will have theta being equal to 315 plus or minus 1 times 360. That's going to give us 360 degrees. So I'm going to search in that direction, giving me theta 315 minus 360 is going to be equal to negative 45 degrees. But in the positive direction, 315 degrees plus 360, that's going to fall outside my required range. Now grouping all the solutions in ascending order, it means that my theta is going to be equal to, I've got a positive 45 and a negative 45, so I could just write them as plus or minus 45, or I've got also here positive 315 and a negative 315. Putting that together gives us plus or minus 315. So there are 4 solutions that will satisfy that equation. In the final example, we want to solve this one here, where tan theta is equal to the square root of 3 for minus 360 is less than or equal to theta, which is less than or equal to 90 degrees. Okay, so proceeding in the same manner, I'm going to look for the key angle, which is going to be equal to the inverse of the square root of 3, and this is going to be equal to 60 degrees. Looking at my original equation, I can see that tan theta is positive, so it is going to lie in the first quadrant. So the first quadrant is a solution. So the first quadrant, so it's your cast diagram. So it will lie in the first and the third quadrant. But you'll notice that if I draw a new diagram here to show the location of the two angles, this one is inclined at 60 degrees. Then the second one is also going to be found here. So that's also going to be inclined at 60 degrees. Now let's go ahead and then find the general solution for tan theta. It's going to be equal to, so theta has to be equal to 60 degrees plus or minus n. Now the graph of y is equal to tan theta is going to repeat itself after every 180 degrees, so it'll be plus or minus n 180 degrees, and again n is equal to 0, 1, 2, 3 and so on. Now if I look for this second angle, which is going to be 180 degrees plus the 60 degrees, so the second one, the second general solution of the theta is equal to 60 plus 180 plus or minus n 180. So theta is going to be equal to 240 degrees plus or minus n 180. What we now need to do is then abide by this restriction that's given in our question. So we look for solutions that are going to be less than greater than negative 360 but less than 90. So when n is equal to 1, when n is equal to 0, theta is going to be equal to 60 plus 0, so that gives you 60. When n is equal to 1, theta is going to be equal to 60 plus or minus 180 degrees, which is going to be equal to, so when it's 60 plus 180 degrees, you'll get 240 degrees, and the other one is going to be 60 minus 180 degrees, giving us negative 120 degrees. When n is equal to 2, I'm going to have theta being equal to 60 plus or minus, when it's equal to 2, it'll be 2 times 180, and that gives you 360 degrees. So I will have theta being equal to 60 minus 360. It's going to be minus 300 degrees. 60 plus 360 degrees falls outside my required range. Now, grouping everything in ascending order, theta will be equal to minus 330 degrees. The next one is going to be equal to minus 120 degrees. Next one will be 60 degrees, and the largest value is going to be 240 degrees. In fact, 240 is greater than 90, so it is not a solution. It's got to be less than 90 degrees. So that's not a solution to the equation. So 60 degrees is the largest value that will satisfy this equation. Now, if we use the second general solution to find the solutions to the equation, you'll find that you'll obtain the same values that we got using this first one. In fact, that's one thing that's unique about tan. You'll just need to work out one of the general solutions and you'll obtain all the other solutions from it. You don't need two. Well, that brings us to the end of this tutorial. In the next one, I'm going to be talking to you about finding or solving trig equations that have got multiple angles or compound angles. I trust that you found this to be useful, and I will see you in the next one. Cheers.